Welcome to The Explainer. Today, we're jumping right into the high-stakes world of scaling infrastructure and the critical decisions that can literally make or break your business. Look, if you're building, managing, or investing in digital platforms, you already know that growth is the ultimate goal. But what actually happens when that massive growth finally arrives?
Take a look at this massive number, $775,000. That's the estimated lost sales J.Crew took on the chin during a catastrophic Black Friday website crash. It wasn't that nobody wanted to buy their clothes, it's that their architecture simply couldn't handle the sudden flood of buyers. Turns out, too much love can absolutely crash your servers. And when your system buckles under that pressure, it's not just an IT headache anymore, it is a massive, immediate hit to your bottom line.
And get this, Google found that 53% of mobile visits are just totally abandoned if a site takes longer than 3 seconds to load. 3 seconds. That perfectly proves that unscalable architecture costs real money. Performance isn't just some nice-to-have bonus feature anymore, it's an absolute necessity for survival in today's digital landscape.
Here is the roadmap for today's explainer. We'll cover the cost of system failure, vertical versus horizontal scaling, the big three of cost, downtime, and risk, speed versus long-term elasticity, and finally, we'll look at the diagonal hybrid solution.
All right, part 1. The cost of system failure.
Imagine you're the founder or the lead architect. Your app goes viral overnight. Boom. You're in the driver's seat, and you have to rapidly pick an architecture path before your users even notice a slowdown. The choices you make in this kind of pressure cooker moment are going to completely define your platform's future.
Which brings us to part 2, vertical versus horizontal scaling. Let's break this down using a super simple car analogy. Say you suddenly need to deliver a lot more boxes. Do you take your one existing delivery car, rip out the engine, and drop in a massive high-performance V8? That's vertical scaling. Or do you go buy a fleet of 10 smaller, standard cars to distribute all those goods? That's horizontal scaling. So, diving into vertical scaling, also known as scaling up, the crucial thing here is that it concentrates all your power in one place. You're throwing more RAM, extra CPUs, or faster disks into one existing machine. Now, this is incredibly fast to implement, largely because you usually don't even have to rewrite your code. But it comes with a hard physical ceiling. You can only buy so much hardware for one machine, and worse, that single giant server becomes a massive single point of failure.
On the flip side, we have horizontal scaling, or scaling out. This means adding more machines to work in parallel behind a load balancer. This is literally the highly resilient foundation of modern cloud architecture. It's exactly how Zoom scaled up from 10 million to over 300 million daily users in a matter of months. But there's a catch. It's complex. Your app actually has to be designed to run in a distributed way from the start.
Moving on to part 3, cost, downtime, and risk.
I highly recommend grabbing a screenshot of this matrix because it completely maps out the exact business trade-offs you're facing. Just look at the downtime comparison. Vertical scaling usually forces you to take your system offline to upgrade the hardware, which means actual, painful disruption for your users. Horizontal scaling lets you snap on capacity dynamically while traffic is still flowing. And regarding failure risk, if your single vertically scaled mega server crashes, your entire business stops dead. With horizontal scaling, if one server out of your fleet of 50 dies, the others just absorb the shock and keep going.
Next up, part 4, speed versus long-term elasticity. I absolutely love this quote from a Netflix presentation by Josh Evans. Everything is trade-off. It's such a great reminder that in system architecture, perfect simply doesn't exist. You literally cannot have the fastest, cheapest, and most resilient system all on day one. You have to make intentional compromises based on what your business needs right this second.
And this illustrates that exact tension perfectly. Vertical scaling is your band-aid. It's your quick fix to survive the day. Horizontal scaling is your complex but deeply resilient long-term strategy. Look, if your database is melting down today, doubling its RAM gives you immediate speed and breathing room without making your team rewrite the entire app. But if you want long-term elasticity to handle truly massive, unpredictable traffic spikes, you absolutely have to invest the engineering hours to break your app into microservices that can scale horizontally.
Let's hit our final section, part 5, the diagonal hybrid solution.
So how are the absolute biggest platforms handling insane growth without going bankrupt? The answer is diagonal scaling. They are blending the raw, cost-effective muscle of vertical scaling with the infinite elasticity of horizontal scaling. Basically, you build up one really strong server, scaling vertically until you hit the absolute best cost-to-performance ratio. And then you scale out horizontally by stamping out exact clones of that highly optimized machine.
Just look at this node graph. It honestly looks like a galaxy or maybe a junior developer's worst nightmare. This is actually Netflix's architecture after they transitioned from a single monolith to over 700 independent microservices. It's insanely complex, for sure, but this beautiful web of interconnections is exactly how they hit 99.99% uptime. If one tiny node in this galaxy fails, the rest of the system just reroutes the traffic and your movie keeps playing without a hitch.
Now, out in the real world, this hybrid approach isn't just about servers, it's an entire ecosystem of strategies. We're talking multi-tiered caching so that traffic rarely even touches your database. Google Cloud Retail Apps actually dropped database queries by 92% just by adding a solid caching tier. You're using dynamic orchestration like Kubernetes to automatically scale horizontally. You're separating and sharding databases. And you absolutely must have CI/CD pipelines because elite teams are relying on automated tests to safely push code out to this massive fleet hundreds of times a day. To help you bring this all home, here's a brilliant 5-step framework from the team at Coderio that you can use on your own infrastructure right now. Number 1, find your real bottleneck. Is it CPU, memory, or database locks? Number 2, check if your workload can actually be distributed. Number 3, be brutally honest about your downtime tolerance. Number 4, check if your team is really ready for the operational headache of distributed systems. And number 5, weigh your need for an immediate short-term fix against your ultimate long-term growth limits.
I want to leave you with one final provocative question to chew on before your app gets its next crazy spike in traffic. Will your architecture survive your best day? Because if your product goes viral or your marketing campaign totally knocks it out of the park, the last thing you want is for your infrastructure to be the reason you miss out on the rewards. Thanks so much for joining me for this explainer. I highly recommend sharing these frameworks with your engineering teams today, and I'll catch you next time.